Hello everyone, this is Bhumika and today we are going to solve internal test 1 numerical data analysis question paper. So let's begin. So question 1, we are tasked with writing algorithm to perform operation on a polynomial px of degree n as given in the equation. The operation are evaluating the polynomials at point x, dividing the polynomials by x, are computing its derivative. We need to compare two approaches for each task: brute force technique and recurrence approach method. So let's begin. For task 1, we have to write algorithm. First, initialize the result equals to 0 for each I from 0 to n. Compute xi that requires I multiplication. Compute ai dot xi that 1 multiplication. Add the term to the result 1 addition. Now return the result. Time complexity 0 bracket n minus 1 by 2. Exponentiation within the loop causes this higher time complexity. Now for recursive approach, given algorithm, start with result an for I from n minus 1 down to 0. Compute result equals to result dot x plus a. Return the result. Given program, function Horner coefficient matrix n comma x. If n equals to 0, return coefficients 0. Return x into Horner coefficient 0 matrix. Its time complexity 0 n. Only one multiplication and one addition can done. Now task 2, divide a polynomial by x minus r. We have given algorithm for brute force iterative approach. First, initialize the quotient coefficients array q to size n. Second, for each degree I from n down to 1, the leading term of the dividend gives the coefficient q I minus 1. Subtract the term q I minus 1 dot x minus r from the current polynomial, which involves multiplying and subtracting for each term. Third, the remainder is the constant term after division. Now for program, function divide by linear coefficient matrix comma r. N equals to length coefficient, p equals to array of size n, b0 equals to coefficient 0. For I from 1 to n minus 1, bi equals to coefficient I plus b I minus 1 into r. Return b in matrix 0 to n minus 1, that is quotient. Its time complexity is 0 n minus 1 multiply n by 2. Now for recursive approach, given algorithm, initialize the quotient coefficients array q to size n. Set q n minus 1 equals to an. Third, for I from n minus 1 down to 1, compute q I minus 1 equals to ai plus q I dot r. 4, the remainder is a naught plus q 0 dot r. Now program, function recursive divide coefficients n comma r. If n equals to 1, return no quotient. New coefficient equals to recursive divide coefficient n minus 1 comma r. Next term equals to coefficient n minus 1 plus new coefficient n minus 2. Multiply r if n is greater than 2, else coefficient matrix 0 multiply by r. New coefficient multiply append, that is next term. Return new coefficient. Its time complexity 0 n minus 1. Now third task, dpx by dx minus derivative of the polynomial. Algorithm, initialize a new coefficient array for the derivative size n. For each I from 1 to n, compute the new coefficient I minus ai. The new degree is I minus 1. Third, the constant term's derivative is 0, so the result has degree n minus 1. Now program of brute force iterative approach. Function derivative, coefficient, null matrix, n equals to length, coefficients, derivative coefficient equals to array of size n minus 1. For I from 0 to n minus 1, derivative coefficient I equals to coefficient I multiply n minus I minus 1 written derivative coefficient. Its time complexity is 0, n multiply n plus 1 by 2 if multiplication is counted as multiple operation. Its recursive approach program function recursive derivative coefficient matrix comma n. If n equals to 1, return null matrix. Partial equals to recursive derivative coefficient comma n minus 1. Current equals to coefficient n minus 1 star n minus 1. Partial dot insert 0 comma current, return partial. Its time complexity is 0 bracket n. Moving to next question, that is write the algorithm or flow chart of the following tasks and complete the table. So we have given 3 tasks and we have to complete the table, given data 1 and data 2, and we have to fill error message and final results. So let's begin. Here for subtraction we need to compute the values of n1 and n2 and find difference between n1 to n2. So we get 0.5452e minus 99 minus 0.5424e minus 99 equals to 0.0028e minus 99. Second, very small values can cause underflow. For large values like 0.5452e3 minus 0.5424e3 equals to 0.0028e3 equals to 0.2800e1. So, small differences after Lagrange subtraction result to loss of significance. So, moving forward for multiplication, we get 0.1111 E151 into 0.4444 E50 equals to 0.4937 E201. That result to overflow. Second, 0.1111 E10 into 0.1234 E15 equals to 0.1370 E25, but only 4 significant digits stored, so 0974 lost. So basically we need to compute the values and perform operations. So for division we need to divide and put the values. We get 0.9998 E1 divided by 0.1000 E minus 99 equals to 0.9998 E101. That result to overflow. Now moving to the question number 3, verify associative law and distributive law of arithmetic with fitting 4 Manchester digits and provide correct answer if no number is truncated. We have given 2 expressions. First one, a plus b minus c not equals to a minus c plus b, comma, a equals to 0.5665 E1, b equals to 0.5556 E minus 1, comma, c equals to 0.5644 E1. Second operation, a in bracket b minus c not equals to ab minus ac in bracket, comma, a equals to 0.5555 E1, b equals to 0.4545 E minus 1, c equals to 0.4535 E1. So solution, associative law verifications. So we have given values a, b and c and given expression. So starting from the left hand side, in bracket a plus b minus c, first, a plus b equals to 5.665 plus 0.05556 equals to 5.72056. Result 5.721. Second, in bracket a plus b minus 6 c equals to 5.721 minus 5.644 equals to 0.07700. Now RHS a minus c plus b. First, a minus c equals to 5.665 minus 5.644 equals to 0.02100. Second, in bracket a minus c plus b equals to 0.02100 plus 0.05556 equals to 0.07656. Result to 0.07656. Now, resulted LHS equals to 0.07700. For distributive law verification, we have given values a, b and c, and we have to compute the values of a, b and c in the expressions. So, for first expression, LHS equals to a into in bracket b minus c. First, b minus c equals to 0.04545 minus 4.535 equals to minus 4.48955. That results minus 4.490. Second, a into in bracket b minus c equals to 5.555 into in bracket minus 4.490 equals to minus 24.94295. Result minus 224.94. Now RHS a into b minus a into c. First, a into b equals to 5.555 into 0.04548 equals to 0.25241. Result 0.2524. Second, a into c equals to 5.555 into 4.535 equals to 25.17543. That results 25.818. 3. In bracket a into b minus in bracket a into c equals to 0.2524 minus 25.18 equals to minus 24.9276. That results LHS equals to minus 24.94 and RHS equals to minus 24.9276. So similar LHS and RHS. So final conclusion, both associative and distributive laws fail under floating point arithmetic with 4-digit mantissa, constraint, rounding errors and loss of significance. Moving to the last question, that is true or false. So first, minimizing arithmetic operations helps reduce computational error and improve performance. That is true. Second, subtracting nearly equal numbers can cause catastrophic cancellation, so it should be avoided or done with caution. Third, when adding or subtracting a sequence of numbers starting from the smallest helps preserve precision. That is true. Fourth, due to rounding errors, it is dangerous to check if a floating point number is exactly 0. That is true. Fifth, ill conditioning can arise from poor problem formulation and can often be managed by reformulation and sensitivity testing. That is true. Sixth, numerical instability leads to error accumulation in each step. Algorithm should be treated for stability. That is true. 7. If rounding errors are unavoidable, using double precision is recommended to maintain accuracy. That is true. 8. Double precision uses more memory and may slightly slow down computations due to increased data size. That is true. The relative error of 0.0013 for the Newton-Raphson method cannot be confirmed as true without exact computation, usually needs verification with actual calculation steps. That is false. 10th, iterative methods are evaluated based on convergence rate, computational efforts per iteration, and sensitivity to initial guesses. That is true. So, Here's all the questions are completed. Keep watching and keep learning. Thank you.